Today we're talking about congruent triangles. So, two polygons are congruent if they have the same shape and size. But today we're going to be focusing on triangles. So take a look at the two triangles in this diagram. If you trace triangle ABC on a piece of paper and put it over XYZ, you'll find that the two triangles are identical. So that means angle A matches up with angle Y, angle B matches up with angle X, and angle C matches up with angle Z. Also, we can see that the length of AB, the side length AB, is the same as XY, or YX, if you will. BC is identical to XZ, BC, XZ, and CA, and CA is identical to ZY. And these lines are just showing which sides are identical to each other. So what we can say is triangle ABC is congruent to triangle YXZ. So the way we would say that, or write that down, important here, so triangle ABC is congruent to triangle YXZ. Notice the order of the letters. It's important here because it shows the relationship between AY, BX, CZ, side length AB, side length YX, so on and so forth. So the above pairs of equal angles and equal sides are called corresponding angles and corresponding sides of the congruent triangle. So when two triangles are congruent, each pair of corresponding angles and each pair of corresponding sides are equal. So, if we're talking about triangles, it has 6 parts, 3 sides and 3 angles. If we want to show that the triangles are congruent, do we have to show that every single angle and every single side length is congruent to each other? You don't. There are some conditions that we can use to test the congruence of triangles. The first type of congruence we're going to go over is side-side-side congruence. If 3 pairs of corresponding sides of 2 triangles are equal, then the 2 sides are congruent. So this is the side-side-side test. Here we can see that AB is equal to DE, BC is equal to EF, and C and AC is equal to DF. So what we have here, if I want to show that these two, or state that these two are congruent, I would say triangle ABC is congruent to triangle DEF after having proven this side, and this side because of side-side-side congruence. Next, we have side-angle-side congruence. If the two sides and the included angle of one triangle are equal to the corresponding parts of another triangle, then the two triangles are congruent. This is also known as the side-angle-side test. So side-angle-side congruence. In this case, we see AB again is equal to DE, but now we're looking at the angle in between here, and so I would say angle ABC is equal to angle DEF. Notice that the middle point here shows the vertex of the angle to which I'm referring to. And then one more side, notice angle BC is equal to EF. So then what I could say is that triangle ABC is congruent to triangle DEF because of side-angle-side congruence. Now, what's super important is the order of the sides and the angles. The angle has to be in between the two sides. Here's why. Let's take a look at these two triangles. Now what you can see here is I have two separate triangles and the angle is not in between the two sides. I have side length 5 over here, side length 5 over here. That's the same, side length 2.7 and 2.7, and angle 30. In this case, even though I have two sides and an angle, they're definitely not congruent. You could see this third side length is a lot longer, even though I have similar degrees. So in this case, the two triangles may not be congruent. So this would be, for example, an angle side side, and we can't have that. So that does not work as a type of congruence. The next type of congruence we're going to go over is the angle side angle congruence. If two angles and the included side of one triangle are equal to the corresponding parts of another triangle, then the two triangles are congruent. This is the angle side angle test. So in triangles ABC and DEF, what we're going to see is angle ABC is equal to angle DEF. We can see because these two markings show that they're the same. We have side length BC equal to side length EF, and then we also have angle ACB equal to angle DFE. So then that means triangle ABC is congruent with triangle DEF, and that is due to angle side angle congruence. It passes the angle side angle test. So the last type of congruence we're going to go over is the right angle hypotenuse side congruence. In this case, what we can see is that angle C and angle Z both equal 90 degrees. So we can say angle ACB is equal to angle XZY. Again, they're both 90 degrees. We can see that side length AB is equal to side length XY, and we could see that side length BC is equal to YZ. Now you might be saying, wait a minute, this kind of looks like angle side side. It kind of does, but in this case, if the hypotenuse and one side of a right-angled triangle, that right angle is what's important, are equal to the corresponding parts of another right-angled triangle, then both triangles are congruent. This is also known as the right angle hypotenuse side test. So the difference here is that because that's a 90-degree angle, if I were to stretch out one of these triangles, I would then have to stretch out this side in order to compensate, and it wouldn't end up being the same length, which would also alter this angle as well. So that is why the right angle hypotenuse side congruence test is different from the angle side test. So what we can say then ultimately is that triangle ABC is congruent to triangle XYZ due to the right angle hypotenuse side test. So those are the different types of congruence that we will be dealing with. What I want you to do is think about all those different types of congruence, and you're going to try this out. In the figure, ACE and BCD are straight lines. AC equals DC, BC equals EC, and DE is 8 centimeters. So what I want you to do is name the triangle that is congruent to triangle ABC. So state the rules and the reasons. And then I want you to find the length of section AB. Good luck.